Hi there, Stefan.
Okay. Welcome everybody, and I'll go ahead and share my presentation. Is everybody able to see the title page?
Yep.
Okay.
Working.
Okay, good. So today we're going to talk about, for some reason I can't see the audience, but I'll just forge ahead assuming. Anyway, okay. So today's agenda I've kind of sketched out. We've got some kind of a short set of videos and some notes that Philippe Delmier, I can't pronounce his name, kindly provided. He was interested in the subject, so he offered some videos. This, for some reason, let me tinker with this for a second, because I actually can't see anybody, and it's hang on a second. There we go. Nope, that's screwed up. Well, I'm going to try this again. Sorry, just a second. Okay. Just bear with me for a second. The first thing, can everybody see the YouTube? Yeah. Okay.
See it.
Okay, good. So the first thing we're going to do is watch a couple of videos that Philippe presented to me. So they're short. Everybody can see the video. There's no sound to this one.
Yeah, video's playing.
Okay. This is just about over. Okay. Second video.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away.
Sorry, madam.
It's just a matter of observation. The real question is, how observant were you?
Action.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
Okay. So could everybody see those all right? I think so, right?
Yep.
Okay, good. I still can't see the audience, which is a little weird. So, but okay, as far as the first video goes with the triangles and the squares, we kind of get the impression that they're understanding it's nothing more than an animation, but these notes that I'm going to present are pretty much what Philippe mentioned about this. And he said the triangles and the circle appear to have intent, emotions, and understand what happens. So it looks like they kind of understand. He says at one moment, the circle goes outside the square through the door, looks at the triangles fighting, tries to approach, but is afraid, steps back to hide. But really it's a trick. All there is two triangles and a circle moving. That's all. And you added a lot of context and built a story around these figures and trajectories. You suppose that these things have a mind simply because they move in a particular way that is compatible with some actions and emotions you know. And you consider a situation through the filter of your internal world and add non-existing properties only because they're compatible with some previous experiences. Basically, the point of this is to illustrate the extent to which we seem to impose, or we attribute understanding to the mere appearance of understanding. And in the second video, the video with the whodunit, it's interesting because a lot of the information there was you still could understand what was taking place, but quite a bit of changes took place or happened, and it didn't affect the outcome. So a lot of information is useless, forgotten, skipped, but you could still put together this understanding somehow. If the incoming information does not contradict the model you have in mind, the understanding is still coherent. So I thought that was pretty interesting. And now we're going to move on to reading. I'm going to just display something for you to read. Here's an example of something to read, not an endorsement, but pretty simple. The reason I displayed that was to illustrate the extent to which understanding happens far beyond the immediate sensory input. So, I mean, I think, if I'm not mistaken, probably when everybody saw the sign, it conjured up a pretty much complete understanding. But the understanding is really not. It's based on far more than just the mere words that appear. Everybody with me so far? Again, I can't see anybody. So, hello?
Yeah.
Okay, good. All right. So Philippe had several notes or several points to make about reading and understanding. And he was inspired by the Kinch model, which is a two-part model. One piece being the input stimulus, the text you read or the sound you hear, and the other being the set of cognitive abilities you possess and the knowledge you have in memory. The cognitive ability allows you to build a specific structure in mind and integrate it in other structures to build a context. So kind of two pieces working together, the input, that makes complete sense, the input and the cognitive abilities in the Kinch model. And he noted that we use microprocesses for the text and macro processes representing an abstract of the important data. So micro and macro processes. And interestingly, when we read, a lot of the text processing is rapidly forgotten. You forget the phrase pretty much as soon as you read the next one. And but the semantic part remains in memory. And we don't process all the input data in the current text. If you've already got a global correct representation, then you might not need a specific piece of text. And you can skip around, automatically focusing on what should be relevant if it fits your current interpretation. So he noted that, in other words, we make predictions of what's relevant. We are reading along. We've got some of the text. We don't read all of it. We've got a semantic understanding. We make predictions about where things are headed, and then we focus on some piece of text. So it's in a way intuitive. If you don't really think about this, you might think, well, we just read everything, remember everything. But it doesn't really work that way. It's selective. You can still, the fascinating thing is how you can get an understanding with just some of what you read. So understanding can be viewed as a process which assembles and integrates semantic context. We need multiple functions, of course. Pretty much everybody who studied cognition understands this. And Philippe mentioned another work in the Gerns-Bottcher work, which I've got these in the references, but he pointed out that suppose you're reading a story and you make a note of what the major characters are, and those characters stay privileged even when not mentioned. So you keep certain things when building up an understanding. You keep, for a story, you keep certain characters in mind. And importantly about this Gerns-Bottcher work, it's what you focus on at the beginning of the process of understanding creates the context. So it seems like what you start out with is pretty much what you wind up with. Okay, so most people have seen this, these pretty famous images, psychological images. And notes about that are, it's a process of understanding can be viewed as a process which builds things together and tests integration. So it's partly unconscious. We can think of it as partly unconscious, certainly not totally conscious. And we're looking for a correct integration. And it seems to work in a hierarchy too. So lower to higher. So like in that previous, those images, you could focus on some part of it and then still understand the whole, and it all seems to fit and flow together. But okay, so this is the principle of coherence. Or this illustrates the principle of coherence. Well, I got this from this definition from the American Psychological Association, and meaningful interconnections between distinct psychological entities. Okay, for example, a system of independent beliefs that's logically consistent from one belief to another would be described as coherent. That seems to me to be pretty important in AI as part of understanding. Do you have a system of beliefs that integrate logically from one belief to another? Okay, so in this case, we pretty much everybody since childhood has sometimes seen these images. They don't work. You've got the stairs that lead upwards to infinity. You've got the screws that I don't know how to describe that. What this illustrates is failed coherence. So this is Philippe's writing here, and I'm pretty much just reading what he wrote. Is by processing these images part by part, you recreate a context for them. Extracting for each partial step for each step partial information to use for the next step, modifying them in a failed attempt at global cohesion and coherence. It's especially true with the screws, where you will not feel comfortable with the image and perceive variations in your mind. Well, failed coherence. And this is a theme that I've seen coming up in the survey. There seems to be levels of understanding, and people talk about this in different ways, but in a kind of a hierarchical fashion. We're trying to assemble these pieces, and it doesn't work for failed coherence. So this brings me to the main points, pretty much the conclusion of my little intro. And understanding is automatic. We automatically attribute understanding to the mere appearance of intelligent behavior. So, like this is the this goes back to the triangles and the little circle chasing each other around. If it looks like if some automation or some animation looks like it's intelligent, we seem to automatically think it understands. And that animation was from 1944. They didn't even really have any way of doing automation like that, well programmed. The second point is from that whodunit video. You could still obtain an understanding of some situation, even if a lot of stuff is ignored, missing, incorrect. You can still understand it. So you don't have to get a perfect understanding of everything. You just have to understand what's important in the context. And as you know, I tried to illustrate with my Trump sign, your understanding of something is based on concepts not attributed directly to the actual sense input. So what we understand goes far beyond what the sense input is, typically, not always, but typically. And in coherence, we strive for it's kind of a global integration. So I'll post the this little intro in the archives, but I didn't read much of these of Philippe's references, but here they are if you guys want to look at them later. So that concludes my presentation. Any comments at this point?
What you've said seems to make sense to me, and is pretty consistent.
Okay. Can you still hear me?
Yeah.
Okay, good. I see. I'm having a little bit of a technical issue here. Let's see. I seem to have lost my screen altogether now. Just a second.
A question would be, is perhaps people aren't aware of, as to what technologies are already out there that are not being utilized, which will actually do some mimicking of the skills that you've sort of outlined in your list of abilities. I think anyway. Perhaps I'm digressing, but because the simulation technologies allow you to do many of these things, but they're probably not very well known to people.
I can mention that the phenomenon of that humans tend to attribute understanding to things like the animation with the triangles and the videos. It has a name. It's called the intentional stance. There's books about it by Daniel Dennett mostly. And in the intentional stance, you tend to attribute understanding and the intention specifically to anything where your attribution of intentions makes your life simpler. So if it helps you to think of your Roomba as having intentions, it wants to go into bedroom next or stuff like that, then that's the stance that you want to adopt and typically adopt. It's a very low level. People talk to their cars, people talk to their Roombas, people talk to their cats. Anyway, it has a name, the intentional stance.
Well, when we look at an animation, we expect some kind of symbolic presentation. So, in some sense, I have to say that I often look for rational or explainable reasons for something occurring. So that's sort of similar to an intentional stance.
The interesting thing, though, is that I find myself using intentions as a metaphor frequently for things that I know don't have intention. So it's like there's layers of it. There's actually believing that something is acting with intentionality, and then there's just using it as a convenient way to describe the behavior.
Sorry, I'm having technical difficulties.
Mike, you might want to unshare your screen. There might be another window on top of it. If you unshare and then reshare it, it'll help.
Hear us, can't you, Mike?
Okay.
Oh, okay. Yeah, good point. Sorry about that. I disappeared for a few minutes. So,
and just another, when you share, there's supposed to be a side-by-side option when you share, so that it'll show what you're sharing and the participants. It's supposed to be in the share button itself. But
it seems like it every time I come into Zoom, something changes and what used to work doesn't work.
What are you trying to share? Are you trying to share the list of definitions?
Well, we can get started on that if you guys want to. Yeah, do you want to start the critique? Unless there's any more comments about those intro videos.
On animations, I think that a way of using animations in simulation to represent the operations that underlie understanding, underlie meaning, is a way of linking the very basic elemental text phrases. If you've looked at the linguistics of it, there's actually 65, according to one group of researchers, that are sufficient to build an ability to paraphrase sort of the human tree of knowledge. So for me, that's the place to start, and to actually animate, in 2 and 3D, those that set of 65. I mean, these are concept words that are universal to all languages, but they're things like the word "this," which obviously, has a context of probably just before you experience the word "this," if someone's speaking, they'll be nodding at something or picking up something and shaking something. So this is entailed with an animation that involves being within arm's length of something or shaking of something. Although that's actually the English translation. In a lot of languages, the word this would also mean that or those over there, because they only have one word for pointing at something. But the concept is that I am focusing your attention on something it's an ability that chimps and we share, in terms of this is something that's important to me, kind of thing. These are the skill sets that we need to implement as firmware to actually be able to start communicating intention. That's my view.
We did have many people write in definitions of, or their thoughts on understanding. I could share. I don't know what we have here. just like I can read a couple, like Michael Miller's Understanding Is Model that allows accurate prediction explanation of phenomena, and Jim's was Understanding is based on knowledge that has potential to act as a partial explainability, and which can be adaptive to new knowledge and or experiences that fit well into that knowledge. My question is, does understanding require the ability to explain? Like, do humans explain things to other humans, but I don't know if animals do. Thoughts?
It seems like explanation is really the test part of that. So
well, also, I'm sorry. Also, in addition to explainability, I'd say be able to react appropriately to situations. So I've sort of changed my definition. So I'd add that, be able to react appropriately to situations that have been encountered before, or types of situations that have been encountered.
I think explanation means that you've actually got to a point where you are wanting to share an understanding as an intention, a communicative intent, but actually, within your own mind, you can actually understand something, but without being able to explain it.
Also,
go ahead.
Well, also, you want to be able to explain why an artificial intelligence program makes some sort of decision.
So one theme that I think I'm picking up here, not explicitly stated, is cause and effect. So maybe if we get away from the idea that explanation has to be verbal, if you understand the cause of something, you have in effect explained it to yourself.
Yes. The process of discrete event simulation is something that I think is a way to represent words as individual functions, mathematical functions, in a sense, in that they have a precondition, a process activity, and then they deliver something out. But they, rather than being a flat mathematical function, these are functions that are animations in effect. They affect 2 and 3D space over time. So those are the cause and effect explanations that words have.
Can I extend on that? Just make it a black box scenario where I've tested and I understand when I do inputs, I get certain outputs, and I do the extensive testing. So I have a whole list of things I can send to the black box, and a reliable, reasonable expectation of what I'll get out of it. And I can communicate that whole set to somebody else, and they can experience the same thing. So I have a understanding, I've been able to communicate it, but I have no explanation of what happens in that black box of why that I'm getting those results. So do I have understanding without explanation?
I guess I would say in that case, maybe we're conflating different levels here. You understand the input and output of the box, but maybe you don't understand what's going on inside the box.
Could I come in here and suggest that, in terms of my answer, about simulation, is to think about Searle's Chinese room, which has got a massive amount of information in, and actually what it needs to be, in a sense, is a room that you visit, but actually the contents of the rooms needs to be sliced and diced, so that individual words, in effect, go into component like rooms themselves. That we every word is well, if you know the experience of what's it called, an operant conditioning chamber, if you know that terminology. This is from animal behaviorism, where if you imagine a pigeon is experiencing a set of educational circumstances where they can press a button when a light gun comes on and food is sort of shot to them. So the word up, you know, you could think of it as a, I'm trying to remember the name of the it's S somebody or other.
Talking about Skinner.
Skinner, yes, Skinner, yeah. So if you think of words as being like a virtual version of a Skinner box in virtual reality, but as a reusable component-like tool, actually it's a discrete event simulation element component. Then that's how you can string understanding together, because you've simplified the contents of Searle's Chinese room into elements. You know, it sliced it up. Anyway, that was my where I'm heading at the moment.
I want to point out that we continue to use the word understand in different ways. We use it as a noun, as something as an understanding. You have an understanding. And then you use it as a verb and you start saying, well, I understand something and you understand it. And okay. When we confuse the two, I like the Mike Milner or whatever was the first one on the list there, that one there, Miller, because he says an understanding is something. It says what it is. It's a model. And then you go on to say, well, you have a model. What can you do with it? Well, that's where you start talking about all the different ways you can use your understanding. And that's where you talk about, you can explain something, you can recognize something. It all comes from having the understanding, which is the model, and then applying it in some way. So I kind of like the distinction of making between the understanding as a thing and what it is, and then it's as a verb and all the ways in which you use it. I put that into my last definition.
Actually, Brett, we can, if you want, we can just discuss your definition right now. So,
sure. Yeah, I started with a number of early ones.
Yeah, so I guess I was kind of thinking for this meetup that we could pretty much take a look at all of the definitions one by one in turn, and Jim spent some time compiling the highlights of each definition, so we don't have to actually read every definition right now to follow along. But I did put the survey up at the top of the chat, so you can read the full survey as well. You could bring it up in a different screen if you'd like, for example. But anyway, Brett, this is your this is what we actually, I added some of what Jim had put on here, but there's several aspects, it looks like, to your definition.
Yeah, one is the understanding as a model is a pretty in-depth structure. Second one is it's you feel that it's reliable. You have belief in it. You feel it's true, and that reliability allows you to do your things that you do with it, like explain it and all the other ways in which you apply that model as an understanding. So there's the in-depth aspect, there's the reliability aspect. There's also the concept of how complete it is, how consistent it is. Those were some aspects, you know, how good the model is in terms of consistency, you know, referential integrity, all those kinds of qualities that you put around a model. That determines how good your ability is to use that model, to apply it.
It seems like you were talking, that's basically the issue of coherence. That, yeah. So it's, you know, when I was reading through these, I do see the same kind of themes recurring. And you know, one thing I was thinking of, which is kind of aspirational, is that, you know, perhaps towards the end of today's event, or you know, later on, we could try to compile the most common themes that are recurring in here. And, you know, that might be a kind of a group definition of understanding.
I like that idea.
Yeah. So, I mean, you know, coherence comes up a lot, and that makes sense because it's part of the kind of official psychological definition. And levels too. There seems to be levels. There's.
I was just wanting to say that you know, you're talking about depth and you said levels, but I'd see it more as a hypergraph, so that it's both a hierarchy that contains embedded elements, that then the embedded elements can also be parallel. So it can be a network within networks of interrelated processes. So actually, you know, we're thinking of understanding of being existing in two places in terms of a reference library of past experience, and also, you know, that is a hypergraph. You could think of it as like a brain structure or the internet as a hypergraph structure, but also there's a hypergraph that is, you know, current cognition, current truth, current experience, current global workspace. So yeah, you know, the depth, and I'm with you on that, Brett, with what you're saying there.
Yeah, I like it. I like your hypergraph idea. It's making basically what they call a semantic model, where you all the links to the verbs and the nodes of the nouns, and you basically end up representing all possible sentences effectively.
Yeah, well, if you create an autonomous driver for these simulation tools by using language, you know, then you can dynamically construct hypergraphs. I think that's the plan.
Yes. Brett, you know, one thing I like about your I
was just going to say where each link in the hypergraph is a noun, verb, noun, as in a simple sentence. Sorry, Mike.
Yeah. Well, that's okay. I was kind of interrupting myself anyway. But what I like about your definition here is that you know, so understanding being a verb. So there's this I that understands something, and I guess there's a subtle. This is a thinking person's game here, and it's not so simple, right? So there's that which you understand, and then there's the process by which you understand.
Yeah.
There's so I guess it's important to keep that kind of distinction in mind.
Yeah, I like to use the word have. You have an understanding, and the understanding is a model. Therefore, you have a model. And the model, it could be a hypergraph, a structure.
It seems like to me it's a little easier to say you understand an idea, but I mean,
there's a set of phrases associated with a set of conceptual elements, elemental concepts. These elemental concepts are universal to everyone's. I'm getting off. This is maybe a separate topic of you know, I will probably end up saying too much if I start talking about the work of Anna Visbeker and Cliff Goddard on the language of thought, but that may be something for another time, because there's a universal language of thought, a universal grammar associated with their work, where you were talking about the word I. They describe for I and you and me the universal uses of I in all languages. So they say for I, there may be 4 grammar usages of the word I in all languages, but that isn't saying something about language. That is actually saying about the human cognitive use of the concept I. It's part of our brain's firmware in the meaning of the word I. So there are about 150 phrases associated with these concepts. So that, yeah, it's a lot more than just uses of the verb and stuff. But it's a fairly contained set of, you've got 65 elements and about 150 phrases, which is very cool because it's enough to paraphrase language.
Okay, hey, why don't we move on?
Sorry.
I noticed Stefan Verbeek had logged or joined in.
Yeah,
and,
that's a long list.
Yeah, so your focus is on understanding stories, and but you kind of look at all understanding in kind of in terms of it's like a story in a way, I suppose, some situation. Did you have any comment?
So from my point of view, I approach this as a programmer. So for me, understanding is the question, not in the sense of how does a human understand something, but in the sense of how can we make a computer understand something. And a computer has totally different hardware than a human is using. So we also have to use a different approach. What's working for BioWare, for the human brain, is not feasible for a computer. Computer doesn't have the capacity. It doesn't have the correct type of hardware to do those computations. So if we approach this as a programmer, then we have to isolate a number of things. So there are different concepts in understanding and intelligence, and there are also different questions which needs an answer. One of those questions is how meaning is encoded. By the way, there are still a few people who have their microphone on, which I'm not talking about the moment. I'm having an echo.
Okay.
So the question how meaning is encoded, I think, is the most important question in artificial intelligence at this moment. So the main question is, what's the difference between something that's alive and what's not alive? So what's the difference between a Chinese room and true understanding? How do we know if a computer is just acting as if it understands or whether it really understands? Is there some benchmark how we can test that? First, we have to know what exactly that understanding is. And once we have maybe not a final solution for that, but a hypothesis, then we need a way to test that. So we need to be able to program a benchmark which will tell us if the computer is actually doing something which resembles how a human understands something, or if it's just acting. And when I talk about these things, I like to refer to an alarm clock. If you wake up in the morning because your alarm clock is ringing, then the question is, who is waking you up? Is the alarm clock waking you up? That's one answer. Or another answer would be, you're waking up yourself, because it's not the alarm clock which is doing the ringing, it's you who went to sleep, who has set the alarm clock and has given the delayed command to wake yourself up. So the alarm clock gives the illusion that it knows when to wake you up, but we all know that an alarm clock doesn't know those things. And those things are easy to recognize, but when the behavior becomes more complex, then it's more difficult to see if there's true understanding. Even with humans, you have that. They can replicate a task and not understand what they're doing and still be perfectly professional and achieve good results in what they're doing, but not really knowing what processes that they're using. So one of the things I've done for myself is narrow this down into a list of pseudocode, or call it functional points, which a program must be able to achieve to not demonstrate understanding, but actually do real understanding. So I've made this short list, which is in the description. And one of the points is, well, maybe I have to tell where I start with this. So if I have a computer and I run something, then I need input data. So there's a scenario, a situation, which the computer needs to understand. And we call this, for simplicity, either a narrative or a story, which is the same thing. So a narrative is just a story, is a sequential sequence, a sequential series of events which have been perceived. So a computer or robot has senses, has sensors, and it perceives its surrounding, its environment. And it does not only do that at one point in time, but as a repeating task. So that creates internally in the memory of that computer or in the memory of a computer, what I call a narrative story. And then the computer has to start working with this story. So what does it need to do? Which steps does it need to accomplish to implement understanding? So the first thing which it needs to do is recognition. So we know recognition by convolutional neural nets for complex visual scenes. We know this as OCR for text, which comes in as a visual image. And we also know this as some, like for instance, Fourier transformation. So it exists for sounds, it exists for text, and it exists for live dynamic video. So what does a computer need to be able to do? First, it has to be able to classify the items in the narrative. And what's classification? So you have classification and identification. It's almost the same, but not exactly. If a computer is able to classify something, then it's able to recognize that a certain perceived pattern or sub-pattern is, for instance, a pedestrian or a road sign or a car or whatever. That's classification. But if it's able to classify that perceived pattern is a pedestrian, that's not enough for identification. Identification is classification, but beyond that, also the identification of the instance of that class. So it's not enough for a computer to recognize, okay, this is a human face, but identification is more. Identification allows to say, okay, this is James, this is Brett, this is Colin, who I'm seeing here. That's identification. So those two things at least we need. Without identification, there's no way to understand the narrative of the story. Third thing that it needs to be able is that after the identification of the instances in the narrative, the computer has to be able to identify the actors. Now, what's an actor? If something happens in the narrative, then there's a story. And in the story, there are always actors. Yeah? And I've taken these words, these verbs from the movie world, but I've incorporated them in programming. So if I talk about an actor, that's not a real person acting something, but an actor can also be something like a door, which is opening. It can be something like the weather. So if we say it's raining, then the actor is the weather, is nature. So there's always something doing that act. There's never just happening something without that there's something or somebody that's actually doing this thing. Yeah. So that's the actor. And once you have identified the instances and you have made two distinct separations, identifying the actors and what's being acted on, then you're already 80% on the way of implementing understanding. But we have to be careful, because we can make a system that we can query, and you can ask a computer like, okay, what have you seen? And the computer can tell you, I've seen a pedestrian with a blue shirt and he's sitting on an electric bike. But then it's not understanding. Still at that level, it's still recognition. Now, for most AI researchers at this moment, when they talk about artificial intelligence, then they just talk about recognition. But the convolutional neural net, it's doing recognition. It's not doing reasoning, it's not doing understanding, and it's also not doing planning, And most of all, it's not building a world model, which is essential, because what you learn today, you also want to use tomorrow. So whatever understanding is accomplished, it also has to be stored. And then we get to that concept of integration, and that is that it has to be brought in relation with what we all already know, or what the computer already knows. So if the computer sees something and it reaches understanding, recognizes the actors and what's being acted upon, then it also has to be able to change this world model, create an engram, a memory, a recording of some kind, which later can be used to recollect what has happened before and use that as association, as implication of what it perceives later. Now, to prove that the computer understands something, one of the basic tools that we have is querying it. So we can do this at the level of debugging. I can simply look in the debugger and check if the computer program has created the correct hierarchical sequence of connected things. So even if the computer is not able to tell what it has seen, then I can still see in those data structures that are internal created whether it has perceived what it needed to perceive. Now, if you ask from a system that it's able to make a story of that, so make that it's able to plan a number of sequence of sentences that explain what it has perceived, that goes far beyond understanding. That's not just understanding, that includes planning, reasoning, ability to act upon other actors given commands. So that's, you have to be careful not to put all those things in one pile, because if you want to try to solve all those things at the same time, then there's no way that succeed. So understanding and intelligence, it's not one thing, it's a layer of software. There are many different layers in that, and each layer is doing some different kind of processing, a different kind of computation, different kind of data structures that it stores and retrieves and processes. So there's not one main algorithm which would do all of those. Now, the ultimate way how we can see that the system understands something is if it's able to not only recognize the actors, but also to make a script, a scenario. So in my vocabulary, this goes as follows. So the first stage is the narrative. That's just pure data, what's perceived. The next stage is the scenario. And to convert a story in a scenario, the system has to isolate the actors. So in a scenario, it says that actor is doing that. That actor is now waiting until the door opens. Then the door closes again. So if you look at the scenario, that's really a time-stamped sequence of all the things that are happening, but in function of who or what is doing them. And then the next step is from that scenario to make a script. The script is a special form of scenario in which the computer itself is taking the role of one of the actors, meaning that the system has learned by observation and is able to replicate what it has seen somebody else or something else do. That's the ultimate form, and the ultimate means how you can see that the system has understood something. So if it's not only able to recreate all those data structures, but if it's able to make all those translation steps from the story to a scenario to a script, and then execute that script, meaning that it will do those things that it has seen somebody else do. Now, if we go a bit further in that direction, then you also have language and ability to communicate. And so, but those are really separate things. So you may not expect from a system that understands something that it's also able to formulate this in nice, proper English sentences. that's far beyond pure understanding. And I think if we want to talk about understanding, then we should keep those things isolated, which also means that stuff like the Chinese room and so at this point in time cannot come into the story yet.
Okay, thanks, Stefan. Is it pronounced Stefan or Stephen? Stefan, right?
Stefan. But
okay.
You can make of it what you want. As long as it sounds a bit like Stefan, that's all right for me.
Oh, good. Okay, good. Yeah. Any questions, comments about this definition?
Oh, this is a nice sort of elaborate definition, but underneath it all, how does it stray far from the core definition that there are self-coherent models that align with the evidence? It feels like an elaboration on that basic definition of understanding.
Can you reformulate that? What do you mean by evidence?
So, so evidence could be externally or internally generated signals that that inherently, whether they align with the predictions that your internal models make, whether there is coherence between those two streams. As long as there is coherence, there is understanding. Is sort of one systemic definition, if you will. Is your definition and a more elaboration of that type of definition in a particular kind of understanding, or it strays beyond that? Or are there any contradictions coming up from your definition to that kind of a systemic definition?
Yeah, I'm going to try to answer your question, but I don't know what exactly your complete point of view is. But the system which I'm working on is a bit different from classic AI.
Mm-hmm.
There are different types of artificial intelligence. If you look at this historically from the beginning, one of the oldest systems were expert systems. Expert systems were just collecting knowledge from humans and were able to apply that. For instance, if you have a lot of doctors putting their knowledge, their life knowledge inside the system, which consists of, if I see in a patient these and these symptoms, then it's probably either this or this disease. And to make the distinction which of those 2 or 3 diseases it possible is, I have to do this lab test. So an expert system is able to combine that knowledge of a lot of different physicians or doctors and to tell, if you have these and these symptoms, then as a doctor, you should ask your patients to give a blood sample, for instance, and check a certain value. And if it's above this threshold, then it's probably this disease, and otherwise it's the other one. So that's an expert system. That's not understanding, because the intelligence which is in that expert system is the intelligence of the expert. Then later systems, which are based on the perceptron.
So you mean to, sorry, you mean to say that that system didn't learn it? So is learning part of understanding in how you're approaching it?
Learning goes beyond replication. So
right.
If I'm a programmer, I write programs. So you could say that I learn my computer to do certain things, but that's not true. My computer was never able to do those things that I was able to do. So if I write a program, and this program then later run on 1,000 different computers, then those 1,000 different computers, they do exactly what I've told it to do. So actually, I'm doing those 1,000 tasks. And if I have forgotten to put some certain scenario, exceptional scenario, which seldom occurs, inside my program, that there's a bug, there's a situation which my program cannot handle. That's the difference between learning, which is understanding. If a system has really learned something and it encounters a situation which it is not programmed for, then it should be able from its understanding to derive a possible solution, or it should at least know what intents, what the original goal was of its creator, and be able to derive some other solution which goes towards that same goal, but which is not part of its original programming. That's understanding intelligence and reasoning, and which is more than current artificial intelligence system do.
Yeah.
For instance,
I agree that current AI systems don't have understanding, but they do have learning capabilities. So maybe understanding and learning is a little bit disconnected, as in, is it possible that a system configured in some way is able to understand but not able to learn further? Like, are those two things real? Like, are they related causally to each other, or one leads, like learning may lead to a system that understands, but is it necessary that the system was learned?
That's a tough question.
In that question, is learning or is understanding really static knowledge?
Not static knowledge, but a system that is as is, basically a system that is configured, and as of right now, it is not able to acquire new knowledge or learn new things, but is it still able to understand?
Yes, it is. Yes, it is.
Okay.
I can explain how.
Right.
So, that's actually how I do things. I have an understanding machine in the cloud that you can send test sentences to, and it gives you back its understanding of those sentences. And basically, I have one machine called the Learner, which is running on a Macintosh 2013 CAN Macintosh, and it learns basically English or any other language you want to teach it by just reading text in that language. And it emits a model of language which is then loaded into the understanding machine in the cloud. But if the understanding machine in the cloud will basically understand any document you send it, but it will not learn from it. And this is how we want it, because if you were, for instance, evaluating web pages using an understanding machine of some kind, and it learned from reading what it was reading, then the later web pages would be differently judged than the first ones, because it has learned a lot more in between. We want repeatability in our understanding machine. So that's what I'm building.
That's a good point. The repeatability might be desirable from a product or sort of commercial or utility application point of view, but it's not clear whether an intelligent system that does not learn on an ongoing basis actually is understanding.
It will produce the same. I mean, if I take my learning system and ask it the question, it will basically give me one answer, and then I do the same thing on the understanding system, and it will give you the same answer. So they are absolutely separable. It's not even hard. And a reader-only intelligence, as I call them, are extremely valuable, because if you think about an AI as an extensive program test to run, then you can only have so many in the server in the cloud. But if you have a read-only intelligence, you can have thousands of client processes that are sharing one big read-only image of the understanding of English, and are computing based on that and delivering results left and right at high speed.
Okay.
The major advantage.
I think I would agree with them being separate. Learning can give you more understanding, but if you lost your ability to learn, you would still understand everything that you understand now.
Correct.
Okay. Is there consensus on that point, or like?
There is even a medical condition that has that problem. You can stop. There's medical condition where human can stop learning new things, and they only know what's happened to them before the condition happened.
So I was kind of hoping we could pretty much make it through the list, and I was thinking if we spent no more than like 5 minutes on each. So Monica, since you were talking, did you have anything else to add about your definition? Looks like.
No, I can take questions on it. I think it's pretty good. I'm writing a whole paper. I'm here because I want to see some arguments for and against what I'm going to write about. But that's roughly what I stand for at the moment.
Yeah. Okay. Okay. Jim, we went through Jim's. Brett. Peter Voss's definition, he's not here, but he emphasizes levels. And the simplest level, just being able to respond and behave appropriately. Tell back the information in your own words, know the implications. And then he brings up the I, and deep subject knowledge and skill, cause and effect. That in the survey, I linked to a Medium article that he wrote, which is pretty good. This is just, I just extracted part of it. He's also got a video out there, and he's been interested in understanding for quite a while. So
yeah, I mean, I've talked with Peter on several occasions. Yes, I mean, he approaches it from a cognitive science perspective, psychology perspective, my question to him always is that, okay, is this feels too human centric? And if
that is the problem with everything we've been talking about has that problem.
Right. And because we not only want to know about whether, like, how humans understand it, but how may a chimpanzee understand, or what does an ant understand, or how might what does my robot understand, right? So we kind of have to step away a little bit from the human-centric view of things and see what is a system that understands needs to have, like, how does a system understand? So
I can address that, but like once we have this Peter's things here, I can point out that he talks about to have a personal experience with connection to the I. I don't even think that's necessary. I mean, I can read a book that's written in third person, and I can basically understand what's going on, even though I'm not personally involved. So understanding doesn't have to be tied to an I, in my opinion.
But when you read a book, aren't you still possibly imagining yourself as one of the characters in the book? Like, if this happened to me, this is how I would feel, or something like that?
No, not any more than when I'm watching a television drama.
But it seems like there's still an I that understands. I got into an argument with Greg Heil. I don't know if he's still here, but he didn't think that was Greg. Are you still here?
We can talk about objectively understanding.
It looks like he left.
And objectively, to say, if you want to understand English and you want to know whether you're understanding it or not, you can basically answer questions. If you have reading comprehension questions that you answer correctly, then we can claim that you understand the language. And it's easily proven by switching the questions to a language that you haven't understood, like Finnish, and then you suddenly can't answer anything. And so being able to answer reading comprehension questions, even if they're very stupid, is part of how we basically can determine that you have understanding of language.
Well, why don't we move on to the next one? Let's try to get through these. And Robert Higgins, is he here? He's a regular, but it looks like he's not here. In his view, understanding a concept means that the entity can act appropriately on that concept. The easy way out is just to recognize a glass. That's what, the kind of theme that Stefan was talking about, the difference between recognition and behavior. And again, this theme of levels, word level versus phrase level. So any comments on Robert's?
Again, just like whether learning and understanding are associated, is action and understanding associated? I mean, are they required? Like, is action required for understanding, or understanding required for action? I don't think either one of those is really true.
Once again, I can basically prove the opposite. It's in traditional psychological literature, actions are enough to confirm that you have understood something. Give me a fork, and if they give you a fork, you figure out that they have understood it. Let's see, where was I going with this? What we're doing in my systems, we don't have outputs at all. We don't have words coming out or actions coming out or anything. When the system is reading text, what we're doing is we're figuratively putting an EEG helmet on the system, and we're looking at its internals as it is understanding. And we can deduce from the internal structure of the neural network and the signaling that's going on, which we as programmers have full control over. We can determine roughly how well it understands something. And these things change. You start reading, it understands nothing. You continue reading, it understands a lot more, and it passes better tests.
Does anyone else think action is required for an understanding or vice versa?
Yeah, I have a strong opinion on the subject. When you perform actions, you recognize them. You're able to redo them. You must therefore have a model of action, and the model is the understanding that you have of the action. And you therefore can talk about actions, you can explain actions, you can perform them, and all that represents that you have a model of an action. And that's more than just the knowledge of a thing, as in an object, but it's also a model of events that take place and actions that are performed. So the answer is yes.
A lot of these.
Oh, go ahead.
Yes. A lot of these.
Sorry. That action is required for, or understanding is required for action.
We could use the raise hand feature if we start interrupting each other too much. I don't know if somebody.
I think Jenny was next.
Yeah.
Okay, a lot of these definitions seem to refer to appropriate action. And I think I would agree that understanding is needed for appropriate action, if as defined as maybe action that achieves one's goals or whatever. If you don't have any understanding, then you can still act, but it probably won't be very effectual because it would essentially be either random or reflexive. Is action required for understanding? I don't know about that one.
A counterexample, riding a bike, action, but I don't understand how I'm riding it.
And it's very hard for you to explain to somebody else how to learn to ride a bike.
You don't have a verbal understanding, but your mind has a model that it can reproduce the steps involved. So it must have an understanding. You just don't have a conscious understanding, you might say.
Okay. What about reflex actions?
And computer programs and brains are active entities. They're taking actions.
Sorry, any effective model, there has to be an action learning feedback loop. Otherwise, you end up with you have an action you learn at some point in building the original model. When you act on it, if it doesn't give the results you expect, I would say you don't have a sufficient understanding if you don't modify your concepts based on that failed action. So I feel that learning action loop is critical to the understanding. Otherwise, I'll just go back to it's a static model that somehow you've built and it can only act one way. And I get Monica's point of wanting predictability in a response. So that's a good goal. But in general, for understanding, you expect some kind of loop in there so that the underlying concept can be modified based on future actions.
I agree with you.
We have that in the learning phase. It's in the understanding phase when we're selling the understanding that we don't learn anything more. But absolutely, we have You have to have all of this learning has to happen, and it happens in one.
So your learning phase is effectively when you build your overall base concept model, and then
Correct.
once it's done learning, then that model becomes static, so that it's predictable in future responses. Okay.
Exactly. We strip all the learning out of it and compress it much smaller. It fits in a Raspberry Pi, and now it can understand English.
Okay.
The difficulty, sorry, the difficulty with that approach is that if there is any discrepancy found, then the model, basically something that the model doesn't understand, there is no way for it to correct it within that context.
Yeah, that's how we want it. That's how we want it. Every model that I publish has a UUID on it that's unique. And if that UUID changes for the client, you know you have to retrain your system because it doesn't match the original one, and so on. So there's all kinds of problems like that. So everything is handled with upgrades, just like iPhone releases. You get a new understanding model, and it's better than the previous one. That's it.
Well, thanks. Why don't we move on? I wanted to see if we can get through a lot of these. But so Boris, I can't pronounce his last name. His definition is pretty minimal. It's just recognition. Does anyone agree with this? To me, this is a little too minimal.
Yeah, I would say it's too minimal. It's way more than just recognition.
It is actually, there's a kernel of truth to that. I mean, cognition is mostly recognition, and so it's roughly what my systems do. They recognize stuff that they've seen before, and they're using some kind of compressed version of it. My compression happens to be lossy. I don't know if his description actually allows it to be lossy or not. It's kind of ambiguous, but yeah, that's it basically. We apply a filter of salience.
But you can only say
important
recognition in.
What do you say?
But you can only have recognition in contrast to an overall base conceptual map.
Yes, you have to have seen it before. I mean, you learn new things, and then when they recur, you already have seen them. And that's an extremely important trait from an evolutionary perspective. It gives you an amazing survival rate.
Right.
I've talked with Boris a lot the past 3-4 years. And I know from which point, from which side he's coming. He's working on this system. Yeah, it's also a software implementation. And for Boris, just like for 80-90% of everybody who's currently working in the field of AI, indeed, intelligence is just recognition. They think that at that point it's finished. From my point of view, it's only starting at the point of recognition. You need recognition. But if you don't have recognition, you can input some text, because then you already have symbols. Then you don't need recognition. But everything which comes beyond recognition is still a bit an empty field. If you look at the science of artificial intelligence, there's simply not enough work being done in that field, and it's being neglected by a lot of people. One of which is Boris. Boris thinks if his system is able to recognize things, then it's able for understanding and reasoning and planning, but that's not how it works. If you implement recognition, then that's what you've got, recognition and nothing more.
You can sell it as it is. You can sell recognition as it is. You don't have to have the other things.
Yeah, you have to have reasoning, and you have to have action.
Okay. Why don't we, Immortal Discoveries is on the Gertzel's AGI chat a lot. And his definition seemed to me to fall into the patternism type category. Finding patterns within past experiences.
Sure, that's pattern recognition. That's part of it.
Important, yeah.
Yeah.
Patterns. Any other comments?
That would almost be a pre-human definition. So this is what we inherit just as beings. Ants can do this, birds can do this.
True.
Mm-hmm.
Point.
Yeah, I think this
is
one
not-
is.
I mean,
I think this one you could take the word pattern and replace it with model.
no, that's the point. I actually never use the word model for the lower levels. I say it's pattern recognition at the bottom is pattern within patterns. And I only start using the word model when you get to the top where you have something that's context free. All the patterns in the bottom are tied to our sensory organs like the eyes and the body position, all of those things. If you want to talk about any of those things, you have to go so many levels up so that you have a model, a context-free model, because those you can verbalize.
There's the levels theme again.
Yes, it's absolutely necessary.
I like that distinction of patterns, like animals sense patterns in a forest, and that's different than up into a scale of building a model of what's in the forest. So I like that distinction.
Yeah, if you only focused on patterns as such, would you maybe be at risk of confusing correlation with causation?
Exactly, yeah.
Absolutely, and that's the point, because intelligence is exactly that you must confuse correlation and causation. At the lower levels, all the pattern matching to lower levels is basically jumping to conclusions on scant evidence. And it's very unscientific. That's why we invented science, because brains are unscientific. So you have to build your systems, and AI has to confuse, and AI has to be built to jump to conclusions on scant evidence. Otherwise, it's not an intelligent machine. Surprise.
James Bowery's definition I liked. Can everybody see the highlight, the bullet points? Okay.
Yep.
Okay. There's a difference between knowing pi out to 1,000,000 decimal places and comprehending what it is. And one might say one achieves understanding when one comprehends the relationship between an object and one's decisions.
I would say, I mean, that's a nuance in it. It's a kind of understanding.
Yeah.
Is it possible that the knowing the digits is the pattern and the understanding is the model?
Good point. Yeah, that sounds exactly right to me. He also brings up he says others have brought in the notion of value to the notion of understanding. And I don't think there's any question about that what is valuable in some situation has a big part to do with how well something's understood. And part two of what I've got envisioned for the next understanding event, it's there are some the formal account that I've read by Kristen Thorson, I believe is how you pronounce his name, but he talks about this very issue. So anyway, we move on. Writer of Minds. Is Writer of Minds here?
Yeah, that's me.
Oh, yeah, that's what I thought. Okay. Well, do you have anything to say?
I thought this was pretty concise. I guess if anyone has questions about it, I'd be happy to elaborate.
Basically, this is similar to what James his second point, the value of what some piece of understanding might be. Is it relevant? And the same thing I think I see in the researcher I just mentioned, Dr. Thorson of I believe he's of Iceland, which in part too I think it'll come to light.
Yeah,
so
I think what I was trying to get at here was, can you relate something to something else that has meaning for you? Can you determine what something is going to do to you or for you?
True. Yeah, I mean, this is a this is a good definition. I try to fit it in the context I understand things in, which is the one's personal goals, experiences, and world model are the models. Concept or statement is some form of signal, and determining relevancy or relationship is the comparison between that signal and the prediction by your models. So it feels, does that align with how you think these things?
I think so. I was maybe thinking a little too verbally in this, going with concept or statement, but it could also be some other type of signal, like a visual signal.
Great. I think then we align on the definition.
Daniel Jew's definition, which I liked. I think I saw him in
yeah, I'm here. Thank you.
Yeah. Did you want to elaborate, or were you willing to, or I don't know?
Sure. Well, I wrote a bit more than other people, but perhaps it's I could make it more concise.
It's good.
When we talk about something like understanding, it's this nebulous term that we could cavitate on and spin our wheels trying to get an exact agreed upon definition. I think I picked up on some of the same ideas that other people had written, is that there's multiple levels of understanding. There's pattern recognition, and that we can, if we just look at ourselves, since we can introspect on our own understanding better than imagining the understanding of ants or other animals, we can look at things where we feel like we have an understanding, but we can't maybe verbalize it, and we can't, we have this something we call intuition, which is a type of understanding that is not at this higher level conscious thing that a lot of us think of as understanding, where we're able to express it through analogies or through matching it up to other sub patterns in a graph, like a graph isomorphism. So I wanted to pick up on the idea of that there are these lower level ties in with our older brain and emotions, and lower, I say emotions, but without hedonic tone, gives you this kind of feeling, and we have feelings that are what we maybe would think of as sub-emotional, that are giving us this feeling of intuition, and I use feeling in the definition there, but they're giving us a sense of intuition. They're giving us, helping to nominate different patterns that are coming in through our sensory inputs, and giving us understanding. Like I really like the analogy of, we understand how to ride a bike, but we don't really understand how we do it exactly. And we can have different levels of articulation, let's say, of our ability to understand something. So somebody 1,000 years ago would be able to maybe express some understanding about life, or social aspects, but they might not have the sophistication of someone 1,000 years later that has built upon what we pass down as a society, is how we articulate different aspects of our understanding of complex things like social issues, or even as far as science has progressed us, we're able to articulate things a lot better, but we still call that understanding. And how is our understanding today different than understanding of people that didn't have these tools of science to work with?
It seems like that last point, when you talk about, or the feeling that goes along with understanding, that's where I always get tangled up, because it seems like that's the kind of inseparable from understanding. That's when it gets into consciousness.
Right. Yeah.
Which is but I don't know if you can have understanding without the feeling that goes along with it, and that's a big unknown.
Yeah.
I think.
Yeah, and just I think this is the tip of a iceberg, but a tip of a subject that I've been labeling a lot of topics like consciousness and sentience and understanding and a few others. There's this idea of that comes to my mind as cavitation, where you could spend your whole life debating, what the actual definition of something like consciousness is or understanding is, and you could spend your whole career in your life debating this and not really get anywhere with trying to make something out of it.
It seems like understand. Go ahead. Sorry.
No, go ahead.
But it seems like understanding is somewhat more practical than consciousness. For one thing, people seem to talk about it. You've got natural language understanding. There isn't a natural language consciousness field, but people are working on natural. It seems like it's something that might be implementable, and that was one inspiration for this.
Yeah, and so the way I'm trying to make this more practical for myself is I'm viewing it as let's build a system that can exhibit the behaviors that we would expect of a understanding system, and then when we'll make a step on that journey, and then when we find the new edge case, it's like, okay, it doesn't really look like understanding when you view it in this aspect. Okay, well, now we need to recorrect course and either adjust the way we've built the system or go back and reevaluate the substrate that we're building the system on. Is it generalizable enough to handle, I would say, projections of these behaviors that we see as understanding or consciousness or sentience? So these words are sort of, I guess, groups of models that we have for understanding the world. So the term understanding is just like any other term that we would use in science. Like the Newtonian physics is a model for understanding the world, and there's also relativistic physics that it's a model for understanding the world. But these are all projections of some base reality that we may not ever get to as far as true definitions of things. So in order
Daniel, you and I should talk offline.
Okay.
I would.
That'd be great, Monica.
I think Brett has a question or
Yeah,
comment.
I'd like to make a comment about your last paragraph there. Very, very relevant. In cognitive science, it's called metacognitive feelings, metacognition.
Yes.
And one part of metacognition is meta memory. You can look it up in Wikipedia, meta memory. And it's feelings such as I know that I know that.
Yes.
I know that I don't know that. I know that I can do that. I know that I can't do that. The tip of the tongue feeling.
Yes.
When you know it, but you can't recall it. All of these are metacognitive feelings, and they're very important for whole concept of understanding.
I noticed that in your examples, you started everything with I.
That's
so,
right.
I mean, that's why, I mean, I agree with you. I know others don't agree, but that the I part of this is integral and necessary. But
yeah, that's because to have an understanding, you have to be someone that is an I that actually has the understanding. You have
right.
the
It's
model.
that's if you take that part out of the structure, it seems like you haven't got the whole works.
Yeah, you have to have an agent. You have to have an agent that has the model, and that can use the model and knows information about the model that is metacognitive feelings about the model, such as whether they know that they can or can't do something, know that they do know or do not know something, etc.
Yes, as far as we know, that seems like the right approach.
Yeah.
Sorry if I cut people off. I was kind of hoping to, but I see Colin has been sitting there patiently, and we're up to his definition. And
that's funny because I don't think I knew when did I do this?
Trust me, you did it.
I've done it.
I think I got it out of the Gertzel AGI mailing.
Paraphrase him saying contemporary AI can't do this. That's not what he said, but that's a paraphrase of something he said in the video.
Okay. Yeah. Okay. Sorry, Colin. Yeah, you're right, Jim.
Okay.
This is coming back to me now. He didn't actually write this. We Jim lifted it. It sounded like you, so I put it in there.
Well, it does sound a bit like me, yeah. I don't want to have an argument with myself at 4:30 in the morning or wherever I am at the moment.
Yeah.
My understanding of anything just now is not looking so good. The thing that has occurred to me as this discussion's been going on is interrelating it with my own work is that the idea of an artificial scientist has been central to my approach in creating a machine that's generally intelligent. And the distinction between scientific knowledge, understanding, and other understandings is the degree of its explicitness in terms of the understanding is exported into the natural world outside the scientist, and it's portable to some extent. And in that form, it's actually very useful empirically in detecting the existence of understanding. It's a bit of a big ask to set yourself a goal of creating an artificial scientist, but I have been through a pretty large analytical process, and I put a chapter on the testing in my book, and it's all practical. But one of the concepts that I've seen operating in our discussion here has been the difference between implicit and explicit knowledge or understanding. And I would draw that distinction along the lines of the scientific understanding and a more natural understanding that you might find in an animal. The basis of the intelligence, the hardware, wetware, whatever you want it, if it is truly to be generally intelligent, then you will find that it will contain at least the seeds of a capacity to become a scientist, and the understanding that animals have simply skips the explicit part of it. There is a whole lot of hypothesizing about the world in the actions of all creatures. There's exploratory involvement in an environment which involves an endless succession of hypotheses about what's going on and what's coming next, that evolution has jumped on and found a solution for, and ended up with this meat in here that can hypothesize and get it right enough to survive. So the third category, there's implicit and explicit, and the third one which occurred to me is worth mentioning is the idea of innate knowledge. The birth of wildebeest on the Serengeti, wherever, comes, the animal has a whole ton of knowledge which is innately brought to bear on standing up and running from the lion before you've done anything in the world. But there's pretty much no understanding at all, and so there's this three: innate, implicit, and explicit. And I think the difference is whether or not it's acquired independently by the agent, whatever that is, after it's been bestowed the innate part of its system of understanding the world. I don't know if any of that makes sense. I mean, I'm 3 a.m. My brain's not functioning on all the cylinders.
Sorry to invent this quote from you, though, I guess, but
that's all right. I mean, it's pretty much whoever did it is pretty much got it. It's all in. You've got to distinguish the idea of intelligence as well, insofar as autonomous novelty handling, which I think we've discussed here in the past, is central to the idea that I'm evolving. And I suppose I'm a little different insofar as nothing I'm doing in AGI is using computers. So I don't have an interest in formulating definitions in the way. It's always really interesting to listen to everyone's definitions, but the formulation of them is not central to my my work. So
Colin,
okay.
Colin, I believe your implicit explicit distinction is the same as your dual process theory, or system 1, system 2, as they often call it. Are you familiar with the dual process theory?
Yeah. There's a minefield there. Implicit, explicit. Yeah, actually, no, to me, they're actually quite different things. The dual aspect, the dual aspect part in my book is all to do with the operation of science. Insofar as how science, the kind of knowledge that scientists produce, and in the book I claim that, I hope I prove that we're operating only on one side of that duality in creating, correlating the observations of an assumed scientific observer, which excludes the potential for actually explaining how the scientific observer actually arose in the first place. And it's the other side of the framework which allows that part of the account of a scientist, which is very different to the distinction between the implicit knowledge and explicit knowledge. Both sides of that framework, the two aspects, can become explicit knowledge, written out, verbalized, smoke signals, it doesn't really matter. Or in the case of a human scientist with that capacity, or it can be implicit knowledge in the understanding that a chimpanzee might have of an environment which is never actually written down or exported in any portable way, but operates implicitly within the chimpanzee for it to solve its problems and engage its environment. So
yeah, Colin, all I'm trying to do is to point you to the cognitive science theory called the dual process theory that describes the difference between explicit and implicit knowledge.
Yeah,
that's all I'm trying to point out. It's a cognitive, in cognitive science, that's what they call it.
Yeah, I'm digging up my background on this. It's a while since I've actually delved into it, but the one that I remember most in that regard is Pilchen. He wrote up a whole bunch of stuff on implicit and explicit knowledge, and I sort of align with that. The system 1, system 2 thing,
that was
Daniel Hanneman. Yeah, that one.
Kahneman. I published a video about that, so you can check that out if you want.
Yeah, I will.
Okay.
Yeah, it's all very interesting. Anyway, I've done my bit, so I wasn't expecting.
Thanks, Colin. So it seems like if we did this a little later, it'd be a little out here. It was kind of hard to get all the time
for me.
Yeah,
getting time zones.
I forgot you. It was tough getting Australia in there. Yeah. Well, anyway, Matt Mahoney. His take is similar, basically similar to Boris's, I think, pretty much. To me, it's functionally, I mean, I kind of see, I mean, I see what he's saying. Functionally, if you can translate Chinese to English, then you can kind of make the inference that it's the system is able to understand in a sense. It seems like, again, this is a little too superficial. It's Chinese room sounding to me.
Yeah, I really don't care for this one at all. I think you could predict the next character in a string of Chinese characters without actually being able to communicate using the Chinese. If you were unable to relate any of those Chinese symbols to, say, internal states of yourself or phenomena in the world, then you wouldn't actually be able to communicate with the Chinese, and I would contend you couldn't understand it, even if you could predict it.
Well said, I think. But Matt kind of rejects the idea of understanding in a computer. So
This is the kind of things that we do in the NLP NLU community. I mean, the tests that we are comparing to each other with, such as the glue test, etc. They are of this nature, and this is a typical test of that kind. I use my favorite test is one that swaps words in sentences and tells you which one sounds better.
It seems like this. I mean, this is kind of an understanding in a sense, but you know, with our levels issue, it's only kind of the lowest level in my view.
You
Yeah.
have to start somewhere. You have to start somewhere.
Yeah,
Yes,
I would
try
say-
to climb the.
Sorry.
Yeah, I was going to say that it does feel a little bit like the definition had the word recognizing. You know, understanding is recognizing. It's a bit
Right,
like that.
right. Good point.
It's a bit limited.
Yeah, I'm not
That's where we
wild
are.
about any of the definitions that try to reduce all of intelligence to one thing. Like all intelligence is prediction, all intelligence is recognition, all intelligence is search. I'm not big on any of those. I feel like it makes things too narrow.
Yeah, man, that's true with all. It seems like all of AI is. We can look at things in isolation, but it's integrating all of these things that are going on. And
At a broad level, I mean, it's okay to consider intelligence as a information process, and this is a information theory definition basically, which says compression is intelligence, which is fine. I think understanding needs to add the grounding element. So I mean, the difference between this and sort of truer understanding is that this will hit a limit and won't, like, there are no recourse from that limit in the sense that if there are discrepancies in how you compress and then uncompress, there are errors. This doesn't say how to reconcile those errors, and that's the bit that is also part of understanding.
okay, we've got a 10 or so minutes left. This is just the I think this is the person's user or email handle. Understanding is the editing distance between data points. Well,
another definition that sort of goes at it from information theory, I think, it can be mapped to compression. Like if you know
partial,
that you can compress.
And
it's a very limited definition.
I think so too.
Yeah.
Roman Kaufman. Understanding is the skill of the machine. Machine X understands if it can determine the completeness and consistency of Y according to its internal application domain model. Understanding is the ability to determine if something can ever be actual. He didn't actually write that, but I kind of inferred it from what he was. So I think what this means is that there's this mental picture, and if that mental picture reflects something that can be actual, then that's understanding. Right.
So whether your model predictions aligned with reality.
Yeah. That seems like another important theme. Does the internal picture and imagination correspond with what can actually happen outside, or is it just impossible?
Well, of course, everyone's reality is their understanding, and everyone has a different understanding of reality.
Mm-hmm.
So there is no such thing as reality. There's just a whole pile of agents, each with their own understanding.
Yeah, with their own models.
Yeah,
how things are. Yeah.
I just add to the same definition that it's also understanding is the recognition that your model cannot be actual, that you have an inconsistent model.
Yes.
Yes. So errors between, yeah, your internal model about your models, and the expected precision of what your internal models predict.
And those are metacognitive feelings.
Yep.
I know what I know. It comes down to the concept of belief as well, a true belief.
My systems are much simpler. I mean, they allow for multiple contradictory opinions at any point in time. There's no attempt at all to reconcile or create a consistent reality. There is no model. There's just pattern. It's much easier to deal with.
Then I would say your system doesn't understand. But
It does well on the test.
by my definition, I have to stand with my definition.
Why don't we move on to the next slide? I like this one so much. I made it. It sounded like a poem, not the way I've got it written here, but to understand is to explain why something is the way it is. To be able to explain why you did something. To be able to explain why others did things. It's broad, though. I mean, it's not just here's your pattern. I like that one.
Yeah. I mean, again, it's models. They have predictions whether they align with reality.
It's the cause and effect motif again.
Mm-hmm.
I would like to add something to it. This is something very important. We may not skip this because there's more to it than you would think. There are levels in understanding. Sorry?
Yeah.
There are levels in understanding.
Well, why don't Stefan, why don't you go ahead and then Monica, please? Thanks.
Yeah, we'll make it short. There are levels in understanding, and you have understanding and you have reasoning. Now, like I told before, there are many, even humans, which are able to do tasks without understanding how they do them, what the processes are. Like, I know when I'm hungry, I don't have to understand which enzymes are active in my stomach to know that I'm hungry. I don't have to know all these details to know that if I'm hungry and I eat something, I will no longer be hungry. So, and how this works comes all down to one thing, and that's cause and consequence. So if you're able to understand at a high level, at a complex level, meaning that you're very smart, that you can reason, then in that case, you can explain what's the cause and the consequence and what's the link between them and how you can avoid it or just cause that something happens like that. But how does nature do that? Because if a child starts to learn, there's no reasoning ability there. There's no world model. So how nature does that is by a very simple trick, which is vital that it gets implemented in whatever system should be able to have understanding. And the trick is time, because in nature, by physical law, it's always like this, that the cause comes in time before the consequence. So first comes what causes something, and then happens what's the consequence. Yeah, and what our brain does, and what nature has implemented by Darwinism, is simply make a recording of things happening in time with the added ability to predict, call it prediction, but basically it's simply reading the next step, because we have a recorded sequence, and by stepping over that sequence of things which we already have encountered before, we are able to see in our memory what the next step is and call that prediction or call it understanding, but it's our ability to react to the next thing which has not happened. And that's the thing which gives us the Darwinistic advantage of survival. This is what makes us run away before the lion comes around the corner, which is what gives us the ability to draw back our hand before it's burned on something hot. So understanding is even the basic level of recording and being able to predict that next step. That's already understanding. But if you have reasoning, that's understanding at a much higher level. So we are talking about the levels, but understanding is also already that lowest level, which is a system at an animal, at the mammal level of reasoning, which is able to learn and act and respond, but not able to tell why it does that. So reasoning ability is not there, language is not there, planning is not there. But the act of learning and act on what it has learned, that's enough to implement understanding. So I could agree with that with Monica, that's already understanding. But if you go beyond that, those people have also right, they're also correct, but it's just a much higher level of understanding, which includes reasoning and language and what I understood. That was my point there.
Monica, did you want to add something?
Yeah, this is quick to make it shorter. 3-year-old kids and dogs understand stuff, but they can't explain how they understand it. And you yourself cannot explain how you understand this sentence. So that's completely wrong, in my opinion.
Okay, the next one is I saw this video was making the rounds on the Facebook groups, I think. It seemed I like this. Okay, I remember I got this out of his video. Understandings about the ability to create a worldview expressed with rich knowledge representation, to be able to model inside the machine, inside the person, complex world that's outside, and enhance and update. Well, okay, I think I'm not sure that I think we pretty much covered that. He's just kind of expressed it in a succinct way. Melanie Mitchell, a pretty well-known author and scholar. The word understand is one of those suitcase words that no one ever agrees what it really means. Sounds kind of like a discussion. Yeah. Abstraction and analogy is key. There, if you see if you look at the full survey that I put in the chat, and under her section, there's an excerpt from, I believe, one of her papers, which talks about understanding. I forget the details, but it's a pretty good quote. Okay, and now we'll get to Amal's definition. That I think one aspect of this I think is that doesn't the energy level drops off significantly.
So I'm mixed in predictive processing. That is the current understanding of the computational neuroscience of how brain works. So we can even leave that aside for a bit. This is how you can observe reaching understanding if you're looking at the brain from fMRI standpoint, but we can keep that aside. This is just a statement that says one understands something when their models predictions match with observations. That's pretty much it in my mind. Models are dynamic, the world is dynamic, but the state of those matching up is when the agent says, yeah, I understand this particular set of observations or situations.
Okay, any questions? We technically we're out of time, but if we just stay on for another 5 or so minutes, I think we'll make it through to the end. Any questions about Amal's definition? Comments? Okay. Oh, well, we're done for the day. Out of time, nothing left. So, well, I'm still working on this. Okay. So I was kind of afraid of having to explain it, but to me, understanding, basically the way people usually use it is just that if for some electronics, for some program, it understands if given some input, the correct output results, so that the calculator understands addition, subtraction, that type of thing. An ATM would understand how to make a withdrawal or a deposit. So, I mean, to me, the way people use understanding for technology is, it's usually limited to that. Does it produce the correct output if the correct input is present. That's the way it's usually used. But what's bothered me for a while is that, in AI, people will say, well, our AI understands such and such. And then because it's artificial intelligence, whoever hears that statement, they start to think, does it really understand like me? What does it mean? How much does it, how do we test whether or not it understands? Does GPT understand? There's all these questions that start surrounding AI because we think it's supposed to be like us, right? So that's why, I mean, it seems like it's important to have some kind of definition, to have some kind of awareness at least of this issue. So basically, what I've envisioned is that it seems like everybody that designs AGI starts out with a set of principles that serve as the base and the bottom, the first principles, like what Stefan was just talking about, cost and consequence. So if some AGI is built with cost and consequence as a first principle, in order to test the understanding of this AGI, it seems like it would have to frame, it's going to stop it, or cost and consequence is going to be a basic first principle. And so if it's going to explain, if it's going to understand and then explain something that happened, it can put it in terms of cost and consequence. Causality is another first principle. It's kind of like, I mean, a calculator understands addition and subtraction. Okay, those are its first principles. But when you're talking about a human being, mental capacities, it becomes more sophisticated. So I don't know. That's just kind of that's a start of kind of where I'm at. But any comments?
Well, I disagree that AGI must be able to reduce everything it does to its first principles, but I may misunderstand what you were trying to say.
Well, you might be right, Ed, but I'm still kind of working on this, so it's a work in progress.
Well, for instance, an AI program should be able to develop its own principles.
But built on top of what, though? You mean just what you would be like a blank slate?
And trace it back to the program, certain parts of the program, but that's not really reducing everything to its first principles. That's all. Maybe it's just the wording that I disagree with.
Yeah, I think Mike's just trying to say everybody starts somewhere. There's some sort of kernel that an AGI has to start growing from, and that may be different for different designers.
And it seems like that's the limit. So if you ask an AGI, how does it understand something? It's because this is all I got to start with. That's what I'm building from.
My system starts from scratch. There's nothing when the system starts. It learns everything from the corpus as it goes.
Okay. Tintner's, I got this, Mike Tintner used to be on the AGI list, and I got an email from him, and he distinguishes sharply between, basically, if you've got this inner world, and then again, this is kind of a correspondence of how valid the model is. If you've got a valid model internally, can that translate to the external? What do you call it? What he terms real understanding, being able to translate the pictured world into the real world. So we've seen this theme before. I don't think he's in the audience, so I'll go on.
Well, there is one thing I want to say. Mike Tintner makes me think sometimes as I try to, he's so strident with his viewpoints that I've learned that I can't really talk to him. But
hey, we're recording this,
Well, I have trouble expressing myself, trying to convince him of something. But so translating words and symbols into other words and symbols. a symbol might refer to distributed patterns, and that really started to think it. So it's like if you have a complex distributed pattern, such as patterns, and you can translate those into other complex distributed patterns, then he's wrong. That could be used in PGI.
I had kind of a hard time hearing that later, but thanks, Jim. Okay. Well, this seems pretty self-explanatory, pretty clear to me. Since we're kind of over time, I think we'll. Oh, look who we've got.
Yeah. Yeah. My level of understanding right now is pretty low since I have a cold and pretty groggy. But basically, I think it involves having models that can predict either the present or the future or the past. Causality is a big part of it. I kind of look at, I kind of imagine like an autoencoder where you have, well, say a regular autoencoder that can encode images into a small compressed layer and then generate the same image. To me, that seems like it has an understanding of the structure of images. But if you make it like a fictitious autoencoder that can encode over time, over long periods of time, and generate video, then it should know the causality of objects and whatnot within that. And then you can add some other things like having it look at its own layers so that it can do introspection and say why is that a ball over there? And it can look at, like, say, oh, the edge, it has certain round edges and whatnot. So yeah, so that's what I have.
Okay. Hope that cold gets better.
No, thanks.
Greg Heil, I like this one. It looks like he left. There's no wonder. Understanding doesn't exist. He told me this at the last meetup in person. So yeah, I mean, yeah, it's just a computer. It doesn't understand anything. Okay.
Oh, is he implying that understanding doesn't exist in computers, or it doesn't exist, period?
I recollect that we were talking about machine understanding, but it's a good question.
It's understanding is a dualistic operation.
Oh, there he is. I thought you left, Greg. Yeah.
And seeing as we live, there is no I. There is no I to understand. But more to the point, I expect we're mostly talking about models rather than understanding. We have a model of the world, and we revise that model and so on. Understanding as such involves an I, and I doesn't exist.
Or I is.
That seems controversial to me.
Well, yeah, I mean, there are whole dualistic religions, and they're monistic religions, and I guess I subscribe to the monistic version.
Like Spinoza or something?
Like Daniel Dennett would. Evolution, the material universe is all that there is.
Yes, but I mean, I still exist as a model.
Yeah, as the model. That's right.
That's about it.
That's about it.
But it seems like if you take that approach, you got to revise a lot of our examples. Like Mike just said, his calculator understood subtraction, or earlier we talked about mammals understand, to some degree. So it's like you need to, state whether we allow the I or not Because then if we don't allow it, then we have to explain differently how animals operate and what kind of models they're building.
Those are two very strange examples. I mean, animals and calculators are very, very different. Animals are much more like us, and calculators are calculators.
I would agree, but it's the usage or whether we are allowed to say I or not that forms a discussion.
Well, and I presumes like Descartes, you know, he is famous for having an I. There's a theater in the mind, and you see that. But you can deconstruct that argument very easily by looking at the latency, and there's nowhere in the brain or nowhere in the body that is everything arriving simultaneously and is being projected on a screen as being able to see. So there is no I. You just have a model. Each cortical column has a model of the universe, of how things work. And when that model doesn't work, then you have to revise it.
There is such a thing as a perspectival I in when you start engaging ideas of experience consciousness. All of our understanding originates in that we create of anything is grounded in conscious experience, and that collection of experiential modes is centered on us. It's presented to us. We're the locus of all this activity. So it's kind of a virtual construct. It's as if there's an I, and we go along with it. So that's the experience, that's the perspectival part. And the other part is the sort of epistemological side of it, where the collective knowledge of all this narrative of perspectival experience sums up, and that summation of knowledge could be regarded as some kind of I, the knowledge created by this virtual locus of experience. So it's a bit like money. We all go along with it. We all think it's real. Sorry.
I can recommend that you read Julian James's book, The Original Consciousness in the Breakdown of the Bicameral Mind, where he makes the claim that consciousness came to existence roughly at the end of the Bronze Age, 6000 BC or so.
All right.
And before that, nobody had the word I. If you look at the Iliad, it doesn't have the word I anywhere. If you look at the Odyssey, you have a very different story.
I think that book's been countered since then, but it's still a great book.
It's a counter and
really
it's a great book.
premise.
I exactly agree.
Yeah.
And by the way, I don't believe some of the counters.
Yeah. Now, I is also an actor, and without an actor, there's no action. So there can be no narrative without that there are actors doing what the story is telling. And I is just one of the actors in the story. You can have stories without that I am in it, but others are just other I's. So definitely there's an I.
Okay. Thanks.
It's a convenient figure of speech is all.
Well, we're kind of over time here. So I think just to get through the rest of these, we're almost done. We might as well finish. Philippe, who gave me the materials for the introduction, he kind of made clear that this was just a partial explanation of understanding, and it basically seems to sound similar to a lot of our earlier discussions.
It's learning from your mistakes.
Yeah, right. Okay. And Walid Sabah, probably didn't pronounce it correctly. He published a paper, not a paper, an essay on Medium I'll try to post the links, and his account is a little more formal. This was a good crisp one sentence definition, I thought. So basically he's connecting. He starts with if you've got an utterance, assume that utterance is true. You fully understand the meaning.
So he's connecting.
I mean,
it to
essentially you have the models to generate that particular utterance. Grounded models. Yeah.
Yeah, it's a thinker. You got to sit here. There's anyway. He published a full article on Medium along with this, and possibly I might be able to use it for part 2 of understanding. Rob Freeman, this is the last one. Organization of information, process of forming concepts, getting beneath something. Okay, well that wraps up this event pretty much. Thanks to everybody. Thanks to Philippe, excuse me, who's not here, but I suspect he'll probably review the video later, and Jim for compiling those bullet points, and obviously for everybody who submitted your definition. I'm gonna have to watch the video myself again, because I was every time I try Zoom, something changes and it doesn't work. So I spent some time tinkering with this thing. Any other comments before we sign off?
It was useful for me, I think. Yeah, it was useful.
Yeah, and as somebody, there's no quick. I don't quite buy into the idea that there's a quick definition to this. It's deep.
Yeah, I would like to extend a big thanks to you, Mike, for doing such a good job of this. It's a very challenging subject to try and to discuss, and you've done a wonderful job bringing us all together and making it work.
Yeah, it's my pleasure.
Good talk.
Yeah, excellent job.
Okay, I'll post the recordings as usual, and see everybody next time. Hopefully in a month or so. Adios.
Thanks everybody. Bye.
Bye.